Okay, in this video I'm going over problem 7.4 from Stallings Wireless, and it says here that one complete period of the PN sequence is shown. I don't know where the I lost part of the page here. It seems to be cutting it off. We'll see if we can survive without it. And this is the table he gives, and he gives time steps 0 through 19. He gives data bits, one data bit for each time step, and he shows frequency numbers as well as pseudo noise bits. So this is a system where we've got frequency hop spread spectrum along with FSK. Okay, and so what he's doing is showing you the PN sequence here, and there are 1, 2, 3, 4, 5 times 3 or 15 bits in the PN sequence. And you read part A and it says calculate, how many bits are in the PN sequence, and you're trying to figure that out, and then you read the statement again. It says this is one complete period of the PN sequence. So this is in fact exactly one period, so we have 15 bits in that PN sequence. And that's nice because it looks like an M sequence of length 2 to the n minus 1, where n is 4. For part B, it asks you, let me read the problem statement for you as I go here. For part B, it says, the system makes use of a form of FSK. What form of FSK is it? It's 4FSK, or MFSK with M equals 4. And how do we know that? Because we have 2 data bits per frequency. Okay? And if you have 2 data bits per frequency, that means you have M equals 4. Okay, L is equal to 2 and M is equal to 4. Part C asks, what is the number of bits per symbol? And we can see it's 2 bits per symbol, FSK symbol. These are FSK frequencies. Okay, number of bits is 2 per symbol. That is, we have 4 frequencies in the alphabet. Part D asks, what is the number of FSK frequencies? And I'm going to answer this with 4, which is 2 squared. Now, if we include the fact that we're using frequency hopping as well, then we've got 8 different frequency hop bands, and in each band we have 4 frequencies. So you might answer that there are 32 total frequencies if you include both the pseudo noise, that is the frequency hopped spread spectrum bands, and the FSK frequencies within each band. It asks what is the length of the PN sequence. For part E, it asks what is the length of a PN sequence per hop? Well, it's 3 PN bits per hop. Okay, so the answer is 3 there. For part F, what type is this slow hop or fast hop frequency hop system? It's slow hop, since there are 2 symbols per hop. Okay, so the PN frequency hops are occurring slower than the frequency hop spread spectrum. Okay, and the total number of frequencies is 32, 4 from the FSK and 8 bands from frequency hop spread spectrum. Part H, show the variation of the D-hopped frequency with time. Okay, so here I have a plot that shows all 32 frequencies. Okay, and it shows the actual hops as given in the table. And you can see that we have FSK symbols within each of 8 bands. And so we have 2 FSK symbols within the first band, and then 2 within the 1, 2, 3, 4, 5, the 6th band, then 2 FSK symbols here, then 2 here, and 2 in the same one again. And what they're asking for is the D-hopped frequencies, and the D-hop frequencies are the values 1 through 4. And so in the first two FSK symbols, they're 2 and 4. Here they're 4 and 3. In the next two symbols, in the symbols 5 and 6, they are frequencies 1 and 3. In symbols 7 and 8 and 9 and 10, they're both in the first band, so it's 2, 4, 3, and 3. So this is the plot down here of the d-hopped frequencies. And you can also plot those directly from the data. The data gives you those frequencies. Okay, a 0-1 is a 1, a 1-1 is a 3, a 0-0 is a 0. So if you want to label those four frequencies 0 through 3, you can use these numbers directly from the data. Okay, and I've labeled them. One, I sort of labeled the frequencies both ways here. Here I'm labeling them 0 through 3 at the bottom, and on the vertical axis I'm labeling them 1 through 4. So it's a little bit of a mess there. In any case, that is problem 4 for you. Hope that helps.